So hello everyone, this is Chandan and you are watching the learning field. Okay, so today we will solve the GATE 2017 numerical analysis question paper. Why? Suppose you can ask me that, sir, why today in okay, because we are continuing the theory part. So I thought कि आज कुछ क्वेश्चंस प्रैक्टिस हो जाए. ठीक है, एक थ्योरी क्लास मतलब रिशेड्यूल करके जो नेक्स्ट तो थ्योरी क्लास होगा ही. तो आज क्या करेंगे, आज करेंगे गेट 2017 का न्यूमेरिकल एनालिसिस का जो पेपर सॉल्यूशन है वो आज यहाँ पे सॉल्व करेंगे हम लोग. ठीक है, and why 2017? Because one of our learners comment me some days ago, okay, some weeks ago, that said please solve the Jacobi method questions of GATE 2017 numerical analysis papers. Okay, that's why we take this paper. Okay, already we solved the numerical analysis paper of 2022 and 2021 complete solution, and after covering the theory parts of numerical analysis we will solve the remaining papers of GATE also. Okay, so let's start. And before starting, because the times now for is 11:05 or 06. Okay, so this is odd time, but I can't get the time to make the PPTs or to make the contents. Okay, so that's why this is the time. So please watch the recorded. Okay, I think anyone no one in the class. Okay, but I can take the class. Okay, or I must take the class at this time maybe. Okay, so let's start. And I want, and why think one thing is that कि मैं सोच रहा था कि वीडियो रिकॉर्ड करूँ फिर अपलोड कर दूँ, बट उसमें भी बहुत सारा दिक्कत है. तो आई थॉट कि लाइव ही ले लेते, कोई आए या ना आए बाद में तो अवेलेबल मिल ही जाएगा. ठीक है, तो इसलिए मैं लाइव आ गया. सब पूरा के पूरा अभी भी मेरा जो है ये मतलब पीपीटीज़ को मतलब मेक किया, ख़त्म किया मैंने. ठीक है, पीपीटीज़ में बना रहा था तो अभी ख़त्म हुआ तो अभी क्लास ले लेते हैं. ठीक है, तो चलो. So let's start, and before starting I'm requesting that, so if you new in our channel, if you new in our family, then please like, comment, share and subscribe. Okay, so let's start to solve the questions. So the question 1 is questions from, so there are basically 4 questions of numerical analysis in the year 2017, and the first question is this is a numerical answer type questions. Okay, this is a numerical answer type question. Just a second. So this is a numerical answer type question, and the question is of 1 mark. Okay, the question says that the fourth order divided difference of fx, okay, is equal to alpha x to the power 4 plus 5x cube plus 3x plus 2. Alpha belongs to real number at the points 0.1, 0.2, 0.3, 0.4 and 0.5 is 5. Okay, that is what delta to the power 4 at y0. If y0 value is this 0.1, then this is equal to what? This is equal to 5. And here the function is given fx equal to alpha x to the power 4 plus 5x cube plus 3x plus 2. Okay, so we have to find the value of this alpha. Okay, now we can calculate this alpha by using the direct formula, which is equal to, we can write जो divided difference का direct formula है 5x equal to, you already solved that. I think summation I equal to 0 to n, and f of xi by product of I equal to 0 to n and I not equal to j, xi minus xj. So you can use this formula also to calculate the alpha. Okay, but I personally here choose the difference table. Okay, so for difference table you can the calculations makes some easy, but this is a big problem also. Okay, so we just first here write the difference table. Okay, so the difference table, the values of xi are 0.1, 0.2, 0.3, 0.4 and 0.5. now the given value of fx equal to here alpha x cube plus what, alpha x cube plus 5x x to the power 4 plus 5x cube, alpha x to the power 4 plus 5x cube plus 3x plus 2. So this is the value of fx. Okay, So we just put the values of xi to this to get the these values. Okay, fxi, fx1, fx2 and so on. So these are the values of fxi's. These are the values. Okay, now delta y means what? This equal to y equal to fx. Delta y means this minus this by this minus this, and after calculation we get this one. And delta y2 is equal to this minus this by what? This minus this, so we get this one. Okay, so then after that this is the divided difference table. Okay, you just calculate the divided difference table to calculate the values. Okay, so the next this one is this minus this by this minus this. Okay, so like this is the difference table. Delta cube y means what? Delta cube y means this minus this by 0.4 minus 0.5, and the last one is this one, and which is equal to this term minus this term by what? 0.5 minus 0.1. okay, so this is the fourth order difference, divided difference. Okay, and it is given that the fourth order divided difference equal to 5. Okay, so 56 alpha by 24, this is equal to 5. This gives alpha equal to 2.14. okay, so this is the required answer of the problem. So the answer is 2.14. okay, so this is the answer of the problem, and this is a numerical answer type question, and the question is of 1 mark. okay, so going to the next question, this is also a numerical answer type question, and the question is of 1 mark. okay, so the question says that what? Okay, so if the quadrature rule integration 0 to 2 fx dx is equal to c1 f0 plus 3 c2 f of c2, where c1 c2 belongs to R, is exact for all polynomial of degree less equal to 1, then c1 plus 3 c2 equals to what? So this is a very easy problem. So since fx is a polynomial of degree less equal to 1, therefore we can take function fx, this is equal to ax plus b. okay, now it is given that integration 0 to 2 fx means ax plus b, which is equal to c1 f0 means what? So f0 means here simply b, and f of c2, this is equal to what? A c2 plus b. okay, so c1 into f0 means b plus a c2 plus b, 3 into a c2 plus b. okay, so this is implies integration means ax square by 2 plus bx. From integration 0 to 2, this is equal to what? c1 plus 1 into c1 plus 3, this into b plus 3ac2. okay, so this implies this is equal gives what? 4 by 2, so 2a plus 2b. I think yes, this is true. This is equal to c1 plus 3 into b plus 3a c2. Now equating both side, okay, we get what? The coefficient of a and b, we get c1 plus 3, this is equal to 2, and what? 3 c2, this is equal to 2. okay, so this implies what? c1 equal to minus 1 and c2 equal to 2 by 3. So we get the values of c1 and c2, and now we need what? We need c1 plus 3 c2. okay, c1 plus 3 c2, this is equal to what? Minus 1 plus 3 into 2 by 3. So this is equal to minus 1 plus 2, which is equal to 1. Therefore our required answer is 1 here. okay, so this is the second question. This is also numerical answer type question and of 1 marks. okay, so our required answer is 1. okay, so go to the next question. The question says that let px be the polynomial of degree at most 2 that interpolates the data minus 1 2 0 1 and 1 2 if qx is the polynomial of degree at most 3 such that px plus qx interpolates the data these 4 points, then the value of q3 is equal to what? So here given that px is a polynomial of degree 2, therefore we can take px, this is equal to ax square plus bx plus c. okay, now this interpolates these data, that means what? P of minus 1, this is equal to 2, this gives what? This gives a plus what? Minus 1 means b, so a minus b plus C, this is equal to 2, number 1. Then P0, this is equal to also 1. This gives what? Simply C equal to 1. This is 2 from here. Okay, and the third point is 1 2, that is P of 1, this is equal to 2. This gives what? P of 1 means, so A plus B plus C, this is equal to what? So this is equal to 2. Okay, this is 3, and here we put the values of C. This implies A plus B plus 1, this is equal to 2. That means A plus B, this is equal to 1. This is 4, and from 2 we get, now 1 implies what? We put the value here, so A minus B, this is equal to 2 minus 1, this is equal to 1. So we now solve the equation 4 and 5, A and B. So if we add, then this gives A, 2A is equal to 2. This implies A equal to 1 and B equal to what? A equal to 1 means B equal to 0. Okay, that means we get the values of A, B and C. Okay, that means Px equal to what? Px is equal to what? Ax means x square plus 1. So this is the Px. Okay, this is the Px. Now Qx is a polynomial of degree at most 3 such that Px plus Qx interpolates these 4 data points. Okay, now how can we solve this problem? If we just erase these points, we don't need this point now. Okay, we just note the Px. I forget to add a blank side here, that's why this is the case. Okay, now it is given. So suppose suppose Qx equal to, we take, this is 3 degree polynomial, therefore we can take ax cube plus bx square plus cx plus d. Therefore Px plus Qx equal to Px plus Qx, this is equal to ax cube plus bx square plus cx plus d plus x square plus 1. This means a x cube plus b plus 1 into x square plus cx plus d plus 1. Okay, so this is the value of Px plus Qx. We take this is equal to Rx. Okay, so Rx equal to this one. Now this interpolate the given data points, that is what? Okay, now Rx gives R of minus 1, this is equal to 2. That means what we get? Minus A plus B plus 1, give bracket here, B plus 1 into 1 plus Cx, that is minus of C plus D plus 1, this is equal to 2. This means what? Minus A plus B minus C plus 1 plus 2, and this is also plus 2, this is equal to 0. Okay, this is suppose equation number 1. The next one is R of 0, this is equal to 1 from this. So this implies R0 equal to 1 means what? 0 plus 0 plus 0 plus D plus 1, this is equal to 1. This implies clearly gives D equal to 0. Okay, so we get one value D equal to 0. Now the third one gives R1 equal to 2. R1, this is equal to 2. This gives what? R1 equal to 2 means, so A plus B plus 1 plus C plus D plus 1, this is equal to 2. Well, that means, so, and put here D equal to 0, so A plus B plus C, and here 1 2, and right side is also 2, this is equal to 0. Suppose this is number 2 and this is number 3. Okay, so A plus B plus C equal to 0. Now R2, this is equal to 11. This gives what? R2 equal to 11 gives 8A plus B plus 1 2 4 into b plus 1 into 4, 2 square means 4, plus from this equation, okay, c 2c plus d plus 1, and this is equal to 11. Okay, that means 8a plus 4b plus 2c plus 5, and d value is 0, so plus 4 plus 1 5, 5 plus 1, sorry, 4 plus 1 5, total 5, and this is equal to 11. Okay, that means what, we can write 8a plus 4b plus 2c, this is equal to 6, and from this we can write 4a plus 2b plus c, this is equal to what, is equal to 3. So this is suppose equation number 4. Okay, now how can we calculate, or how can we solve these three equations? Now from 1 and 3, from 1 and 3, we suppose if we add these two equations 1 and 3, then what happened, then just we get b and this b, that is 2b equal to 0, 2b this is equal to 0. This implies what, b equal to also we get 0. Therefore we all get b and d equal to 0. Then if we put this in equation 4, then 4 implies what, implies 4a plus c, this is equal to 3, since b and d equal to 0, and we get from 3 implies a plus c, this is equal to 0. Okay, now if we subtract these two equations, then we get 3a, this is equal to what, this 0 3, that means a equal to, we get 1. Okay, a equal to 1, and this implies c equal to minus of 1. Okay, therefore what we get, then rx, sorry, not rx, px, sorry, qx. So qx, this is equal to what, from this equation, okay, from this equation we get qx equal to what, xq minus x. Okay, so qx equal to this. Now we need to calculate what, we need to calculate the value q of 3. Okay, therefore simply q of 3 equal to what, I just write here q of 3, this is equal to 3q minus 3, this is equal to 24. Okay, therefore our answer is here 24. So this is the third question, and this is also a numerical answer type question, which is of 2 marks. Okay, now going to the next question and last question for today, and one of the aspirant or one of the learners also comment for these questions only. Okay, so this is the question, let J be the Jacobi iteration matrix of the linear system, and this is a very important question, this type of questions. Okay, so this is the system, Ax equal to this, so this is the matrix A. So I just write the matrix A here, and there are calculations. Okay, so I just write the matrix A equal to here. Okay, the matrix 1 2 1 2 1 2 minus 4 2 1. Okay, then the question says that consider the two statements. Okay, one is the one of the eigenvalues of J lies in the interval 2 3. What is J? J is the Jacobi iteration matrix. Okay, and question number Q is the Jacobi iteration converges for the above system. So these two statements, and we have to check whether which of the statements in between them are true or not. Okay, so this is the question, and this is the demanding questions for myself, who I think I forget the name, but thank you for comment me for these questions. Okay, so this is a very nice question and very interesting question. Okay, so we have to find the Jacobi iteration matrix. Okay, how can we find the Jacobi iteration matrix? So suppose this is A. Okay, now we express this A as D minus L minus U. Okay, where D equal to diagonal matrix, D equal to diagonal matrix equal to, we can write 1 0 0 0 1 0 and 0 0 1. This is the diagonal matrix, and L equal to negative of lower components or negative lower components, which is equal to, we write here, we just write 0 0 0 minus 2 4 0 0 and minus 2 0. So this is the matrix L, and U equal to negative upper components, which is equal to, right, 0 minus 2 minus 1 minus 2, this one. Oh, so this is 3 matrix, and if we from this relation you can check, or you can easily see that this 3, if we do this operation, then A is the given matrix. Okay, now given Ax equal to B, suppose the system. Now we put the values D minus L minus U into this X, this is equal to B. Okay, so this implies what? D into X minus L plus U into X, this is equal to B. This implies we can write D into X, this is equal to L plus U into X plus B. Now this implies X equal to D inverse L plus U into X plus B, D inverse B. Okay, now the Jacobi iteration scheme we can write here, x n plus 1, this is equal to D inverse, okay, L plus U, okay, into x n plus D inverse B. This is the Jacobi iteration scheme, and this is equal to, we can write J into xn plus D inverse, plus C. Okay, we can write this J. So that means what? That means this J equal to this one. This is the Jacobi iteration matrix. That means J equal to D inverse L plus U. Okay, and C equal to, right, D inverse B. We don't need this part in this question, or for this question we don't need this part. Okay, if we need to solve or any other question, then we need this part, but from the according to the given question we only need this part. Now we calculate the matrix J, and for option P or the statement P, so J equal to what? D inverse, D is identity matrix, and D inverse means again this is an identity matrix. Okay, this is identity matrix from the matrix A. Okay, based on the matrix A, this is not necessary all the time the identity matrix. Okay, because this A given in the diagonal is this 3 1, then this D is only D equal to D inverse, you can write. Now L equal to what? L equal to, we write minus 2 4 and minus 2. Okay, minus 2 4 and minus 2. So now L means 0 0 0 minus 2 4 minus 2 0 0 0 plus this is 0, this is, I think some elements are minus 2 minus 1 minus 2, so minus 2 minus 1 minus 2 0 0 0 0 0. So this is the matrix. Okay, so this is equal to, and identity means the multiply is only this matrix only, so this is equal to 0 minus 2 minus 1 minus 2 0 minus 2 and 4 minus 2 0. So this is the matrix J. Now we have to calculate the eigenvalues of this matrix. Okay, so this is our work for option A, what statement P only. So if we calculate, then minus lambda minus 2 minus 1 minus 2 minus lambda minus 2 4 minus 2 and minus of lambda, this is equal to 0. Okay, now this implies minus lambda into lambda square. This is very important question, that's why I solve this question very slowly. Okay, minus lambda minus 4, I think, yes, this is minus 4 or plus 4, just a second, sorry, minus 4 plus 2 into what, 2 lambda minus, sorry, plus 8, I think, yes, minus 1 into what, 4 minus, sorry, 4 plus 4 lambda, yes. So this is equal to this is equal to 0. Okay, so this implies what, just write here, minus lambda cube plus 4 lambda plus 4 lambda plus 16 plus 16 minus 4 minus 4 lambda, this is equal to 0. 1 4 lambda cancel, this gives minus lambda cube plus 4 lambda plus 12, sorry, plus 12, this is equal to 0. This implies we can write lambda cube minus 4 lambda minus 12, this is equal to 0. Okay, so this is the characteristic equation of the J matrix. Okay, now we go to the statement P. It says that one of the eigenvalues J lies in between the interval. So I just write the this here, lambda cube minus 4 lambda minus 12, this is equal to 0. I think this is the value, yes, minus 2 equal to 12. Now we check whether one root lies between this. So if we write f of lambda equal to this lambda cube minus 4 lambda minus 12, then we check whether the two roots. So f of 2 equal to what, minus 2, sorry, minus 8 and minus 12. I think I write here the right one, sorry, this is 8. So this is equal to minus of 12, which is less than 0, and f of 3, this is equal to what, f of 3 equal to, I think, 27 minus 12 minus 12, which is equal to 3, that is greater than 0. That is, see, at the point 2 the function f lambda is less than 0, and at the point 3 it is greater than 0. That means what, we know that if f a b is less than 0, then one root must lie in between the interval a and b. Therefore one root lies between the interval a and b, that is statement P here is true statement. Now the Jacobi iteration method converges for the above system. So I think this question is already solved in one year, I think this question comes. Okay, now if we solve, there is a theorem, that is what, the theorem is this one, I think aii, that is greater than summation of mod aij. This is the theorem. Okay, that is if this element aii is the middle term element, I just name the theorem, भूल गया हूं मैं, ठीक है. So this is the condition of convergence for the Jacobi iteration method. Okay, this is the method. Okay, so check whether if this is satisfied, then the Jacobi iteration scheme converges. So check. So one first ai means 1, and the summation aij means, and j not equal to I think here j not equal to I. Okay, this is 1 is and this term is not greater than 2 plus 1, this is equal to 3. So this is completely false for the first row only. You check whether the second row and third row, since first row is false, therefore you need to don't need to proceed further, or you don't need to check the remaining terms. Okay, so this is not satisfied. This is the condition of convergence for Jacobi iteration method as well as the Gauss Seidel method, and this is the Gauss Jacobi method. Okay, this is the condition of convergence. aii is greater than summation mod of aij. Okay, from the given coefficient matrix A, that is, this is not the Jacobi iteration is not convergence for the above scheme. Okay, that means what, here Q is false, that means the option is here only B option. Okay, only P is the true option. Okay, so this is the content for this video. Okay, so if you need or if you like this content, or then please give a like to this video. If this content helps you a little bit, then also please give a like to this video, share with your friends, and subscribe the channel. Okay, thank you friends, see you again in the next video. Thank you, good night everyone. Just a second.